Hi, my name is Natalie Huan with my supervisor TS Aslimin Roslan, and my title of bachelor degree project is the fertilizer measuring machine for hydroponic vegetable growing industry. So this is my table content of presentation. I would like to start my presentation on the introduction. The fertilizer measuring machine will be invented according to the fertigation technology. It is the technology used a pressure system to combine fertilizers with irrigation water according to the soil nutrient content through the help of controllable pipeline system. Therefore, in this project, we will be working on designing the fertilizing tools to control the ratio density and also designing the monitoring system on the humidity and moisture level in the vegetable plants. The Arduino Mega 2560 will be used as a brain in this fertilizing measuring machine in controlling the process flow of fertilizer and also the monitoring process. Now, MCU ESP8266 will be used as a media in collect data from Arduino and sent to Blink server through the Wi-Fi communication. This table shows my PSM1 Gantt chart activity from week 1 to week 40. So this is my PSM1 flowchart, which I start with finding our supervisor and then select and discuss the topic. After that, I've done on the proposal written report. And then after the proposal is approved, then I'm going to write on chapter 2 literature review with the post-journal thesis and internet as reference. After that, I will go on to writing on the chapter 3 methodology. So this chapter will be writing on layout design and circuit design. So once the simulation is okay, we are doing some improvement and a recommendation given by the supervisor. After that, we're writing on the discussion and conclusion on chapter 3, and then we have prepared for the FYP1 thesis. Once the thesis is approved, and then we are preparing for the presentation to supervisor and also the panel. Next is the problem statement. So in traditional fertigation process, they use only a tank of fertilizer solution and a water pump to distribute the solution. A timer is set to ensure that the water pump flows on time, for example 6 days a day. And unfortunately, there's no monitoring system. So the continuous fertigation process might cause the plant has excessive moisture, which would cause the fertilizer did not dissolve in the soil. So the fertilizer measuring machine with monitoring system will be implemented to minimize the manpower, control and save water, and also improve the efficiency of fertigation. So throughout this project, we will be facing some obstacles such as controlling the fertilizer ratio density. There's a problem which the ratio of liquid fertilizer is hard to control at the ratio of 1:1 for fertilizer A and fertilizer B. Therefore, fertilizing tools need to be designed to control the suitable ratio to deliver to the vegetable plants. So the objective of this project is develop the fertilizing tool to control the ratio of fertilizer, develop the system on monitoring the humidity and moisture level on the vegetable plants, and also build a notification system when the condition of water level and TDS value are detected out of range. Then the scope of this project is water level sensor and solenoid valve will be used to control the fertilizer ratio flow, and then the monitoring system using the Blink application will be pre-programmed based on the microcontroller using the Arduino IDE software, and then the notification system will be displayed through the LCD, which user able to know when the sensor detected any error for the condition of the fertilizer. The expected result will be based on the objective stated just now. So the fertilizer ratio control tool will be using water pump to deliver the fertilizer from main tank to a measuring bottle, and then the water level sensor in the measuring bottle will be determining the ratio required with correspond to TDS level, and then the solenoid valve will be delivering the measured ratio into the mixer tank. So the monitoring system through the Blinks app, there's a problem with Arduino Mega 2560 does not have Wi-Fi, so we'll be using the MCU as a media on receiving data from Arduino and send data to Blink through Wi-Fi. And then we will use the technique called as serial communication to communicate between Arduino and MCU. And then the water level in each tank is and as the notification system to check for any leakage or insufficient remaining fertilizer. So I would like to go on to chapter 2 literature review, which will be review 6 previous projects related to the fertilizer irrigation system and also the fertilizer machine. In previous research one, this is the intelligent fertigation machine, which has 3 components: pipeline system, computer control system, and also the sensor monitoring system, which this fertigation system without tank and pump. In previous research 2, the author used batch method technique to mix the NPK fertilizer, which the ratio of fertilizer is controlled considering the flow rate of pump with calculation of timing of pumping from the mixed tank. In previous research 3, author used the solar panel as the power source, and it also applied the technology of graphical user interface developed in MATLAB to develop auto and manual fertigation mode. In previous research 4, the author is mainly discussed on the monitoring system and also a simple fertigation system using the DC motor. In previous research 5, author also used the solar panel as the power source, and the author also applied the GSM technology to receive the SMS on the status of water pump depending on the soil condition. In previous usage states, auto used an easy sensor and a few precision made according to two factors, which is the fertilizer volume and the time taken to pump the nutrient solution. So this is the table of comparison previous research 1 to 6. They are mainly comparing the advantages, disadvantages, hardware use, software use, technology use. Discussion based on comparison previous research 1 to 6. The fertilizer ratio control able to be carried out by calculation on flow rate of solenoid valve or venturi pump will correspond to the timing of pumping out fertilizer. This ratio control process can be either manually or automatically. Status of motor sensor value can be monitored through blink or use of GSM technology with the message notification. Power source can be either AC, DC or even a rechargeable battery with solar panel. ESP8265 Wi-Fi module required for microcontrollers such as Arduino. The pipeline system need to be considered when developing the fertigation system. So there are a few common aspects applied in the 6 previous research on software, technology, sensor, and also the actuator indicator use. Next is about the hardware details. The TDS sensor is used to determine the amount of dissolved solid in water and output in ppm. The DHT11 sensor is used to measure the temperature and humidity, which is able to measure at the range 20% to 80% relative humidity and up to 50 degrees Celsius. The relay is used to trigger the component when there is a power supply. Next is the water level sensor, which is surface exposed with parallel conductor and the resistance is inversely proportional to the height of water. The water load solenoid valve will be controlling the opening and closing of pipeline waterfall. And lastly, the soil moisture will be measuring the level of water content in soil. The microcontroller detail is on the Arduino Mega 2560. It is a microcontroller board based on AT Mega 2560. It has 54 digital input and output pins, 16 analog input pins, 3V and 5V external provided to the external component, and the 6 ground pins. It has 256 KB flash memory and also 16 MHz maximum clock speed. It is widely used in 3D printer and robotic project because it provides many input and output pin program spaces. It has high processing power and can work with multiple number of sensors. So the conclusion on literature review is the primary aspect developed a fertilizer measuring machine is on multiple sensors, water pump, IoT platforms such as blink application. Since the growth of crops influenced by nutrient, temperature, amount of water, therefore the monitoring condition of crops is required on the TDS sensor, humidity and temperature sensor, soil moisture sensor, and also the water level sensor. The calculation on required TDS level will correspond to the flow rate of water, pump, and fertilizer level was necessary. And then the software to build the connection of data transmission and simulation such as Blink App, Proteus, and MATLAB. Next, I would like to go on to the methodology part, which will be discussed on 3D layout design, project input and output planning, flow chart planning, circuit simulation, hardware and software planning, and also the overall cost plan. So this is the 3D layout of the fertilizer measuring machine, which we can see there is two main tanks connect with the DC water pump, and the outlet of the water pump will be connected to the measuring bottle, and then the bottle cap will be installed with the solenoid valve to deliver the measured fertilizer into the mixer tank. And then we can see that beside the solenoid valve we will have the DIY DC mixer motor to make sure that the both fertilizer mix well in the mixer tank. So here we can see clearly on the side view, front view and top view of the design layout. This is the block diagram of fertilizer measuring machine. We have TDS sensor inside the mixer tank, and then we have 5 water level sensor in the main tank, measuring bottle, and also the tank mixer. After that, we have 4 input button to manual control the water pump and also the solenoid valve. After that, we have 3 outputs controlled by 8 channel relay, which is the water pump, solenoid valve, and also the DC mixer motor. After that, we have 3 types of output indicator, which is the indicator lamp for the TDS reading, LCD for water level in bottle, LCD for EC reader, and also 3 sets of LED in main tank and also the mixer tank. So this is the system flow chart, which LCD will be displaying the centers, display water level, and displaying TDS level. After that, both LCD will be clear and ready to call for the rest function. So for the function under DHT11 sensor and soil moisture, which they will read the sensor value and then send the data to Node MCU through the serial communication, and then the blink interface will display their corresponding sensor value. So under TDS function, it will read the TDS value, and if the TDS value is greater than 850, red LED will be turned on. If it is in between 600 to 850, green LED will be turned on. If it is less than 600, yellow LED will be turned on, and all these respective TDS value will be displayed on the LCD in ppm. And then on the underwater level, it will read the sensor value, and if the sensor value is greater than 500, the green LED will be turned on. If it's not greater than 500, the red LED will be turned on. Then under relay, it will read the button state. If the button state is low, then relay will be turned off. If the button state is high, the relay will be turned on. Okay, so this is the circuit diagram which will be simulating a tank A, tank B, measuring bottle A and measuring bottle B. So in main tank, we have water level sensor with water level indicator, LED indicator, and also the water pump. The logic state is replaced as the relay, which in state 1 the relay is active, then the DC motor will be triggered to turn on. Then in the mixer tank, we will be stimulating the water level LED the indicator, and then we will be also simulating the TDS display and LCD indicator. In this case, we use the potentiometer to replace the TDS sensor because there's no library available. And then we will be also stimulating the mixer motor in the mixer tank. There's another LCD. This is the LCD used to display the percentage of water level in both measuring bottle. And then we were having the Arduino Mega 2560 with the input output pins. After that, we also stimulate the blink virtual interface by using the virtual terminal on the soil moisture and also the humidity. So this is the hardware implementer, which we have Arduino Mega water level sensor, a resistor LED push button and channel relay, DC water pump, two-way solenoid valve, TDS sensor, LCD, DHT11 sensor, soil moisture sensor, DC motor, and also the MSU ESP8266. And then this is the software implementer which we are using Proteus A, SketchUp, Blink, and Arduino IDE, and also the Microsoft Office. Okay, so this is the cost of project, which overall around 378 ringgit. Next, we will go on to the simulation and result on water level sensor. The water level sensor in main tank and mixer tank will be indicated by LED, where if the water level is less than 50%, the red LED will turn on. If the water level is more than 50%, the green LED will be turned on. And then the water level sensor in the measuring bottle will be indicated by the LCD display, where we can control the ratio by observing the percentage of water level in the measuring bottle in order to control the ratio of fertilizer. And the next is the simulation and result on the water pump or solenoid valve. So the two assumption made where the water pump represent also the solenoid valve, and then the logic state will be represent the push button or the relay. So both actuator will be controlled by relay, where the relay will be controlled by the push button. So as we can see from a figure, when the logic state is high, or we can say the logic state is 1, the DC motor will be triggered and turned on, where the logic state is at 0. In low condition, the motor will be stopped. And then we will go to TDS sensor simulation and result, which the assumption made is we use the potentiometer to represent the TDS sensor. So we will have in LCD display to print the real-time TDS value. So when TDS level is greater than 850 ppm, red LED will be turned on. If it is less than 600, yellow LED will be turned on. If it is between 600 to 850, the green LED will be turned on. And then this is the simulation result on the Blink virtual interface, which we assume the virtual terminal as the Blink interface. So as from the result figure, we can see we are monitoring the humidity and soil moisture on the virtual terminal. So this discussion on methodology is the 3D layout design was drawn to have a quick idea on design the overall visual of the product. And then the water level sensor with LCD display, TDS sensor, and solenoid valve are the main component in controlling ratio of fertilizer in measuring bottle A and B. So the monitoring through Blink platform on the moisture and humidity of the vegetable plants, and also the notification by using LED and LCD on monitor the water level in main tank and mixer tank, also the TDS level in the mixer tank. There will be the serial communication technique applied for communication between Arduino Mega and Node MCU to connection through TX and RX pin. So the conclusion of methodology is Arduino Mega 2560 is the best choice of microcontroller to make this circuit system. So based on the simulation result, the use of LCD display monitor water level in the measuring bottle enables estimation of fertilizer ratio, and solenoid valve can also be used to control the ratio if there is accidentally pump of extra fertilizer into the measuring bottle. Then the LEDs in main tank and mixer tank help to prevent any leakage or empty in water tank, and also the monitor moisture and humidity level around the vegetable plants through the Blink platform. So the expected result of the simulation is the ratio for fertilizer A and B will be controlled at 1:1 using the water level monitor and solenoid valve. And then there's expected result on online monitoring moisture and humidity of vegetable plants through the Blink's app, and then the notification system using LEDs and LCDs display on the EC level and water level, where the water level sensor with LED is for main and mixer tank to use to check the sufficiency level of remaining fertilizers. The water level sensor with LCDs for measuring bottle will be used to measure the ratio required. And then there will be a serial communication using TX and RX pin in both Arduino Mega and Node MCU microcontroller. So this is a draft planning on PSM2. And then in conclusion, the simulation show a halfway completion of the program development, but there are several corrections in coding needed to be done on serial communication, sensor reading process, and relay control on the water pump, solenoid valve, and DC motor. And then there will be a DIY DC motor will be developed to make sure the fertilizer A and D mix well in the mixer tank, where all the component connection will be tried on the breadboard before solder on the PCB board, and then the several testing on fertilizer level correspond to the EC level needed to be carried out to get the average value of the estimation. So this shows the references on doing the written report. And then you have Appendix A PSA1 Gantt chart and Appendix B for coding of the software simulation. That's all from me. Thank you.